these are your 10-3A notes, operations with radical expressions. Last week we worried about multiplying and dividing radicals, and today we're going to concentrate more on adding and subtracting radical expressions. So in order to add and subtract radical expressions, we have to define what a like radical is. Like radicals are radicals that have the same radicand and same index. So if you remember, in a radical, the little number here is the index, and the radicand is the number underneath. So like radicands would be the square root of 5 and 3 square root of 5. Okay, it says nothing about the number out in front, just that the number underneath the radical sign is the same, and the little number on the square root symbol, which is 2 here, square root, is the same. Another pair of like radicals would be the cube root of 2 and maybe the cube root of our 2. They're the same, like radicals. So the number out in front or the sign out in front doesn't matter. If I have a negative 3 fourth root of 7 and a positive 5 fourth root of 7, those are like radicals. They're like terms. When you think of a variable, they're the exact same. Same index, same radicand. Most of yours are going to be square roots anyway. So some examples of a not like radicals. The square root of 2 and the square root of 3. Even though they're both square roots, one's of 2 and one's of 3. They represent different decimal amounts. The square root of 2 is the decimal that multiplies to give you 2. And the square root of 3 is the decimal that you multiply by itself to give you 3. They're different amounts. If I have the square root of 5 and the cube root of 5, so this case, I have like radicands, but not like indices. This is really a 2 here, and this is a 3. So the first quantity is asking for a number that you multiply by itself to get 5, and the second quantity is asking what number do you multiply by itself 3 times to get 5. They're different numbers. Okay? And so you just got to be careful of that. Both things have to match, the index and the number underneath the radical. All right, so if that happens, to add and subtract these things, we're going to simplify any radicals. We're going to pull out the perfects. We're going to get the radical out of the denominator if we need to, get rid of fractions, do everything we did last week. So if necessary. In the beginning, it won't be necessary. The second part, you're going to combine like terms. We did this with variables. It is the same concept with radicals. You're going to add or subtract the coefficients of the radicals. The radicand remains the same. You are only going to add or subtract the number out in front. Remember, these ugly radicals, the square root of 3 is just an ugly decimal. So you're just saying how many ugly decimals you have. Okay, so I like to think of it as the way we did variables. I like to just relate to that. Very similar to adding and subtracting variables. So 3x and 6x are like terms because they're the same variable raised to the same degree. And when we go to add 3x and 6x, we would get a total of 9 x's. You're just saying how many x's you have. So same concept. If I have 3 square root of 2's, so 3 ugly decimals, and I have 6 more of the same ugly decimals, I have a total of 9 of that ugly decimal. And instead of writing the ugly decimal, we just write it as the square root of 2. So that's exactly what we're going to do today. So pretty simple. Let's go ahead. I got 8 problems to do here. So if you look at number 1, it's just 3 different piles of square root of 5's. Okay, they're all square root of 5's. There's an ugly amount of square root of 5's. And so we're just going to combine it and say, you know what, rather than telling me that I have 6 square root of 5's laying over here and 2 square root of 5's in the middle and negative 5 square root of 5's at the end, let's put that all together and you add 6 plus 2 minus 5. That's 8 minus 5. I have a total of 3 square root of 5's. So I combined the outside number and keep the square root of 5 the same. In number 2, I'm looking at this and I have a couple different like terms. 4 and 6 are like terms. They're just whole numbers, but they're still alike. And then positive 3 root 7 and positive 5 root 7 are alike. So 10 plus 8 root 7. That's your final answer. All right, so for number 3, when I look at that, I see 7 root 3 and I see 3 root 6. They are not alike. I look at this 3. I can't take a perfect out, so it's already simplified. I can't take anything out of 6, so this is in simplest form. I can't do anything with it, so I'll just put ISF. It's in simplest form. There, I cannot put them together. I like to think of that as a 7x minus a 3y. Okay, you would not be able to do anything else with 7x minus 3y. It's simplified as far as you can get. So for number 4, looking at this, there's a couple different like terms. I am seeing a 7 root 2 here, and I'm seeing a negative 6 root 2 here. Just remember the signs. So I have 7 of that ugly decimal out in front, negative 6. I have 1 root 2 left over. So you can put a 1 out in front. You don't need it. I don't care either way. Okay, and then I have a positive 8 ugly root 11s, and then I subtract 4 of those ugly root 11s, so I'm left with 4 square root of 11. So square root of 2 plus 4 root 11. You can't put them all together because they're not the same values. The square root of 2 is an ugly decimal. Square root of 11 is an ugly decimal, but they are not the same ugly decimal, so you can't put them together. All right, let's take it a step further here. So on this page, it's important that we simplify first. If you look at number 5, there is nothing like in that problem. But I noticed 24, my eyes can see that I can pull a 4 out of there. 54, I can take a 9 out of there. And 96, I can take a 4 out of there. And actually, I can take a 16 out of there. So I'm going to do that first. So I'm going to rewrite 24 as a perfect 4 and a non-perfect 6. I'm going to rewrite negative 54 as a square root of 9 times the square root of 6. And then plus the 96 becomes a square root of 16 times the square root of 6. So you just got to know your list of perfects, and you got to try on your calculator to find the perfect and non-perfect. Now you can kind of see a common theme here. All of them end up being a square root of 6. So I'm going to clean this up. The square root of 4 becomes 2 root 6, 2 times root 6, minus the square root of 9 becomes 3 root 6, and then plus the square root of 16 becomes plus 4 root 6. So now that they're all root 6, I have 2 of them. Minus 3 makes negative 1, plus 4 gives me 3 root 6. I want to see that work when we do that. Everything I did there, I need to see on your work. So number 6, let's do the same thing. Let's simplify what we can. Not always do they all simplify, and sometimes they don't simplify to the same thing, but you still have to simplify. So 50, I recognize, is 25 and 2, plus 3 times 32 can be 16 and 2, minus 5 times 9 and 2. So the 25 becomes a 5, so this becomes 5 root 2, 5 times root 2. And over here, the 16, square root of 16 becomes a 4. I like to circle them. 3 times 4 is 12, so I have 12 root 2. And then 9 becomes, square root of 9 becomes a 3. The negative 5 and 3 makes negative 15 root 2s. So remember, every time a perfect comes out, it's a whole number. And then if there was a number already in front of that whole number, they get multiplied together. So 5 root 2s plus 12 root 2s makes 17. 17 minus 15 makes 2 square root of 2s. And that's your final answer. Number 7. Let's skip 7. Let's actually go on to 8. I feel like 7 is just a repeat of everything we've done. So number 8, we're going to do 6. 18, I'm going to rewrite as 9 and 2, square root of 9, square root of 2, plus 4, square root of 4, square root of 2, and minus 3 times 36 times 2. I guess I was looking for one where they give you 2 radicals, but I'm not seeing it here. Square root of 9 becomes a 3, Because there's a 6 out in front, they get multiplied. 18 root 2. Square root of 4 becomes a 4. 4 and 4 make 16, plus 16 root 2. If you're not showing that work, crossing off, circling those numbers, you're going to make a mistake. I do that for you. You need to do that as well. Square root of 36 becomes 6. Negative 3 times 6 is negative 18. Root 2, they're all root 2s. 18 plus 16 is 34. 34 minus 18 is 16 root 2. Done. Okay, so that is adding and subtracting. So your lesson summary, give me an example of two like radicals, and then I want you to add the 4 root 5 plus 2 root 20. Good luck.